A portion of this video is sponsored by Skillshare. Insulation. It really is fascinating stuff, and we sure have covered a lot of different types of insulation on this channel, like spray foam, cellulose, fiberglass, rock wool, hemp wool, wood fiber, and polystyrene insulation. Today we're going to discover a new type of insulation, ceramic fiber blankets. This incredible material is used in high temperature environments like kilns, boilers, furnaces, and ovens. It can withstand temperatures as high as 2200 degrees Fahrenheit or 1200 degrees Celsius. In this video, we're going to discover how ceramic fiber blankets are made, how they perform, their various applications, and whether they're a good choice for your home. The production of ceramic fiber blankets begins with the selection of high-quality raw materials, typically 45% alumina, 50% silica, 2% titanium oxide, 1% ferric oxide, and other trace compounds like sodium oxide and magnesium oxide. These raw materials are chosen for their ability to withstand high temperatures. They are melted in a furnace and spun into fibers using centrifugal force. This process creates thin, continuous strands of ceramic fibers. The fibers are collected and formed into a loose mat on a conveyor belt. The mat passes through a needle punching machine that mechanically stitches and interlocks the fibers, creating a stronger and more cohesive structure. The fiber web is then subjected to a heat treatment process called sintering. This process fuses the ceramic fibers together, resulting in a solid ceramic fiber blanket. The final product is then cut into the desired dimensions and packaged for distribution and use in various industries. Another name for ceramic fiber is alumina silicate blanket, or ASB, named after its main raw ingredients, alumina and silica, as we discussed earlier. There are many different brands that produce ceramic fiber. The most popular one is kaowool. The brand name is derived from kaolin clay, which is a soft white clay used to make china and porcelain. However, it can also be melted down into a liquid and turned into fibers to make this insulation blanket. I personally find it fascinating that you can turn solids into a cotton candy insulation material. This process of turning clay into ceramic fibers is identical to turning basalt rock into rock wool or mineral wool, slag into slag wool, and glass into fiberglass insulation. In all these products, not only are the fibers themselves insulating, the air trapped between the fibers also acts as an insulator. These two concepts give ceramic fiber insulation its biggest advantage, the ability to withstand extremely high temperatures. I tested and observed its thermal conductivity and fire resistance with a propane torch and this FLIR thermal imaging camera that you can plug into your Android or iPhone. If you haven't watched my video on FLIR's cameras, I'll link it up here and in the description. I held the propane torch to the ceramic fiber blanket for over 5 minutes. Even though the temperature of the material rose to well over 150 degrees Celsius or 300 degrees Fahrenheit, it did not singe, smolder, or catch on fire. The back side of the blanket was actually cool to touch. It also lost heat pretty quickly after I turned the propane torch off. The front face went from 150 to 82 degrees Celsius, while the back face never went over 40 degrees Celsius. kaowool ceramic fiber insulation can withstand continuous direct flames at 1200 degrees Celsius or 2200 degrees Fahrenheit. Above that temperature, it will begin to shrink, become brittle, and eventually melt. This insulation can play a crucial role in preventing heat loss, improving energy efficiency, and saving money and resources. It has a lot of other advantages too. Ceramic fiber insulation is dense but lightweight. It maintains its shape and structure and is dimensionally stable. It has a low thermal drift or loss of R value over time. After being compressed, it bounces right back to its original shape and thickness. It can be easily cut with a utility knife into any desired shape. It is also very flexible. It can be easily wrapped around pipes, ducts, and other complex shapes. Before we move on to the many other pros and cons of ceramic fiber insulation, I'd like to introduce the sponsor of this portion of the video, Skillshare. Whether you're looking to learn new skills, improve existing ones, or even find new career paths, Skillshare can assist you in your journey. I have found Skillshare's classes on Mastering Productivity by Thomas Frank particularly helpful. It's given me tips on efficiency and effectiveness, developing a professional mindset, and even templates. Skillshare's online learning community has thousands of inspiring classes to help you find your creative voice and style, create passive income, and even be your own boss. If you'd like to check this out, the first 1,000 people to use the link in the description will get a 1-month free trial of Skillshare. So far, we have discussed the making of ceramic fiber insulation and its heat resistance. Now let's discuss its many uses and disadvantages. This product is typically used in high temperature environments in the aerospace, military, and petrochemical industries, but it can be formed into a variety of products. Blankets are used for furnace linings, pipe wrap insulation, and even pizza ovens. Foil-faced blankets are used for welding, soldering, and HVAC ducts. Loose fill insulation is used in expansion joints and chimney insulation. Boards are used for insulation backing and fire blocks. Textiles are used for flame retardant fabric, electrical insulation, and ropes. Ceramic fibers can also be compressed down to make ceramic fiber paper. This product also has excellent fire resistance properties, so it is used for furnace door seals, kilns, and forges as a gasket material. It is bendable and can be easily cut with a knife. However, just like with every material, there are some downsides to handling and using ceramic fiber insulation. This product is not used in homes because it has a fairly low R value of 2.5 per inch, which is lower than mineral wool, fiberglass, and cellulose. Another issue is that it can cause skin, eye, and throat irritation because the loose ceramic fibers can get embedded in your skin and respiratory tract. You must wear protective gloves, a mask, safety glasses, and long sleeves clothing when handling this material. Moreover, the Environmental Protection Agency or EPA classifies ceramic fibers as a possible carcinogen. Prolonged and repeated exposure to this fiber dust can cause cancer and lung damage. For these reasons, ceramic insulation is mainly used as pipe insulation in commercial settings where pipes are exposed to extreme heat. This kaowool insulation also has surprisingly low water resistance. As you can see, water soaked right through all the layers of the material. It immediately compressed and lost its shape. It also performed very poorly to oil, even though ceramic fiber insulation is supposed to have excellent resistance to oils, acids, and alkalis. This material has a very particular set of skills. It has the best fire resistance among all the different types of insulation I have tested, but it fails in most other areas. The fact that it is toxic and can cause cancer is very concerning. I have read some research papers that liken this material to asbestos. Workers who manufacture ceramic wool and even those who work at kilns are exposed to these fibers on a daily basis, which puts their health at risk. To combat this issue, some companies have developed an eco-friendly and biosoluble ceramic fiber insulation that is pollution-free, harmless, and degradable in human body fluids. These new products are made of calcium and magnesium silicate fibers. I find ceramics a truly fascinating field. There are thousands of very useful materials created from similar base ingredients. I recently received this sample of Sunshield, a ceramic-based paint that blocks 85% of solar heat. It can be used on metal, asphalt, shingles, rubber, wood, and even concrete. Ceramic paint would be perfect for shipping container homes because you can't use traditional insulation on the corrugated metal. Let me know in the comments if you would like me to test the Sunshield ceramic paint in this brutal Texas summer heat. Also, let me know what you think about ceramic fiber insulation and if you've used it on your pizza ovens or chimneys. I'll link my Patreon page in the description. If you can support me, I'd really appreciate it. I'm now offering early access to ad-free videos on Patreon as a thank you to everyone supporting me. Don't forget to hit the like button, subscribe button, and the notification bell too. Thanks for watching. See ya.